If you haven't already printed this off, please do so now. For this lesson, I have 3 examples that are using stoichiometry in order to be solved. So remember, stoichiometry is just showing the relationships between the different amounts in a chemical reaction. And we have 2 formulas, which I've shown in the triangle form over here. So you can calculate the number of moles using number of particles and Avogadro's number, or you can calculate number of moles using the mass in grams and the molar mass in grams per mole. Now you can convert between mass and number of particles using the number of moles as well, and we talked about that in previous lessons. So let's take a look at the first question. It says, when nitrogen is reacted with hydrogen, ammonia is produced. So let's start by writing out the equation. So nitrogen is reacted with hydrogen and ammonia is produced. So this is our skeleton equation. We just have the chemical formulas of our reactants and product. So now we need to balance the equation. So I've got 2 nitrogens on the left, only 1 on the right. I have 2 hydrogens on the left, I have 3 on the right. So after I balance it, I'll find that if I put a coefficient of 3 in front of the hydrogen and a 2 in front of the ammonia, now it balances out. I have 2 nitrogens on either side, and I have 6 hydrogens on either side. So now I have a balanced chemical equation. So then the question gets more interesting. It says, if you have 280.20 grams of nitrogen, how many moles of ammonia gas can you produce? And then the follow-up question is, how many grams of ammonia gas can you produce? So this type of question is saying, if I know how much reactant I'm starting with, how much product can I expect to make? And this is a common question that chemists have, and even chemists that work in industrial processes in producing large quantities of chemicals. They want to know how much product can be expected. And there's a lot of different ways, depending on the textbook that you look at, on how to attack these problems. I'm going to show you the way that I do it, and I find that it works really well for me. So I set up a table, mass, molar mass, number of moles. I call this my stoichiometry grid. And then I fill in all of the information that I know. Well, I know that I have 280.20 grams of nitrogen, so I'm going to put that in my table. That's the mass, 280.20 grams of nitrogen. And that's really all I'm told. However, I can figure out molar mass using my periodic table. So if I want to figure out the amount of ammonia produced, my process is going to be figure out the number of moles of nitrogen, use the molar ratio. There's a 1:2 ratio of nitrogen to ammonia. So using that ratio, I can calculate how many moles of ammonia I would expect. Using the molar mass of ammonia, I can then calculate the mass in grams of ammonia. You'll notice I don't really need to find out any information about hydrogen. I'm just going to put a big line through the hydrogen column because I don't really need any information, and I don't need to have it in there. So I'll start by filling in my molar masses. So for nitrogen, that's 2 atoms of nitrogen. Each nitrogen has a molar mass of 14.01 grams per mole, and I have 2 of them, so that's 28.02 grams per mole. If I look at ammonia, in the formula there's 1 nitrogen and 3 hydrogens, so 14.01 for nitrogen, and then 3 hydrogens, each at 1.01, gets me a total of 17.04 grams per mole for nitrogen. I'm going to calculate number of moles of nitrogen. So remember, number of moles is mass divided by molar mass. So I'm going to take my mass, divide by the molar mass, and I will get my number of moles. So in this example, I'm reacting 10 moles of nitrogen. The next step is to look at my coefficients. So I have a coefficient of 1 in front of the nitrogen, and I have a coefficient of 2 in front of the ammonia. That means for every 1 molecule of nitrogen reacted, there are 2 molecules of ammonia produced. And we can expand that to number of moles. If we have 1 mole of nitrogen, there's 2 moles of ammonia being produced. So there's always twice as many moles of ammonia as there are nitrogen. So I can take the number of moles of nitrogen, multiply it by 2, and I'll get the number of moles of ammonia expected. So I can expect to produce 20 moles of ammonia in this reaction. Just remember, part C says how many grams of ammonia is that? Well, we're going to calculate the space up here. Remember, if we want to calculate mass in grams, it's moles multiplied by molar mass. So I'm going to take my moles of ammonia, multiply by the molar mass of ammonia, and I'm going to end up with the mass in grams. So my final answer is 340.8 grams of ammonia produced. Let's take a look at the next example. So I've got a different reaction. This time I'm reacting copper with silver nitrate. And it says solid silver and a solution of copper 2 nitrate form. So here is the balanced chemical equation. And the question is, if 1.43 grams of copper reacts completely with silver nitrate, what mass of silver would be expected to form? I'm going to start by writing out my balanced chemical equation, just like I did before. I'm going to set up my stoichiometry grid, mass, molar mass, number of moles. Fill in the information that I'm given in the question. Figure out what I'm asked to find. Well, it's asking what mass of silver would be expected to form, so I'm just going to put a circle around the mass of silver. And I'm not given any information for the silver nitrate or the copper 2 nitrate, and I'm not asked about what amounts I have of those, so I'm just going to ignore those columns. So my goal right now is to start with what I know, which is the mass of copper, use it to figure out the moles of copper, use that to figure out the moles of silver, and then calculate the mass of silver. So start by finding your molar masses. So the molar mass of copper is 63.55 grams per mole, and the molar mass of silver is 107.87 grams per mole. A lot of students make the mistake of multiplying the molar mass by 2 if they see a coefficient of 2. But you have to remember, this is the molar mass, the mass for 1 mole, not the mass for 2 moles. So we ignore the coefficient when we're finding the molar mass. So mass divided by molar mass gets me number of moles. I have 0.0225 moles of copper. Look at the coefficients. For every 1 mole of copper, there are 2 moles of silver. So I'm going to take my moles of copper and multiply by 2 to get the moles of silver. So I have 0.0450 moles of silver expected to be formed. Number of moles multiplied by the molar mass will get me the mass. So we can expect 4.85 grams of silver to be produced in this reaction. Let's do one more example. So when you read through this question, here is our reaction. It's already balanced. And the question says, suppose a railway worker is carrying out a repair using the thermite reaction, which is this reaction. What mass of iron 3 oxide should the worker use? Here's iron 3 oxide, so what mass of this should the worker use to produce 50 grams of liquid iron? So here's the liquid iron. So we know we want 50 grams of this. How much of this should we start with? So start by filling out your reaction, your balanced chemical equation. Start by putting in the stoichiometry grid, mass, molar mass, number of moles. Fill in what you know. I have 50 grams of liquid iron being produced, and I want to know what mass of iron 3 oxide should I start with. And the general form is start where you know the information, find number of moles, use your molar ratios to find moles of your target, and then calculate mass. So I know that 0.895 moles of iron are produced. So I'm going to figure out number of moles of iron oxide. It's a 1:2 ratio of iron oxide to iron. So I have half as much iron oxide as iron. So I get 0.448 moles of iron oxide. Do my calculation. So I can say that the worker should start with 71.5 grams of iron 3 oxide in order to produce 50 grams of iron. Now, as you go through the practice problems, there are some more complicated questions where the molar ratios aren't just either twice as much or half as much. So you just have to watch out for that, and if you have any questions about it, feel free to send me an email.